Hello, ladies and gentlemen. Welcome. The second day of RSMRD International Conference 2021. I say good morning, good afternoon, good evening to everyone, depending on wherever you are. Welcome once again. We thank you for joining in. We thank you for participating at the opening session and all sessions yesterday. Today's session, the time in Nairobi is 15:04 hours, and we want to start with the session. I want to acknowledge all our sponsors and the sponsors for the entire conference and the session sponsors. Once again, my name is Paul Idude, and my colleague who is going to moderate the session is called Anastasia Wahome. Allow me, ladies and gentlemen, to invite Anastasia Wahome to start the moderation of the session for today. Thank you so much. Anastasia, you're welcome.
Thank you very much, Mr. Idude. Welcome everyone again. I will just start by having a very brief recap of yesterday. We had the theme of science policy linkage to resilience measurements. That was the theme of yesterday's sessions. We started with the opening plenary with guests from our stakeholders and our supporters. And we had two keynote addresses, one on climate crisis and the need for resilience by Mr. Stephen Ramage from Geosecretariat, and Earth Observation, the data piece on climate monitoring by Ms. Adiswa Mlisa from South Africa National Space Agency. Again, we are very grateful to our supporters. We also had parallel sessions, agriculture and food security, weather and climate, water and related disasters, and land use, land management, and administration. Now, today we are going to start with a keynote session between now and 5 p.m. We are using Zoom webinar, so you're allowed to put your questions in the question and answer session, in the question and answer part of this platform. After the keynote session, we will have a 10-minute break, and we want to notify you that we have networking lounges, 2 of them, by some of our supporters, Esri and Digital Earth Africa, and we also have virtual booths for all the supporters and our partners, and you can, if you have a few minutes, please visit them, and that will also be a health break. After the 10 minutes, we'll have the parallel sessions, again 4 of them, agriculture and food security, weather and climate, water and related disasters, and land use, land management and administration. So after this session, kindly choose one of them and log in there. Now, today's theme is Earth observation and GIS tools in climate adaptation and mitigation. And this in recognition of the fact that in recent years, we have seen significant improvements in Earth observations, data sharing, and also developments in GIS platforms, improved capabilities for data access and analysis and visualization, and with tremendous impact on informed decision making. We've also seen recognized that Earth observation data plays a very important role in supporting resilience building, as well as monitoring gains in climate change, adaptation, and mitigation. For this session, we have 3 speakers. One will look at data systems for climate adaptation and mitigation, and that will be Ms. Jenny Franke-Reed from the Bill and Melinda Gates Foundation. The second one will be on Earth observation technologies for land degradation and deforestation monitoring by Mr. Mesha Kenywan-Derito, Space Applications Training Officer at the GIS and Africa Project at the AUC, Africa Union Commission. And the third one will be on Earth observation and GIS tools for climate adaptation in the health sector by Dr. Peter Macharia, Center for Health Informatics, Computing and Statistics, Lancaster University, UK, and also Cambridge Wellcome Trust. Now, without further ado, I want to invite our first speaker, Ms. Jenny Franke-Orid from the Bill and Melinda Gates Foundation, to give us our first keynote of the day. And I'll be projecting that just now. So welcome, Jenny.
Thank you so much, Anastasia. It is just an honor to join this 2021 RCMRD International Conference. What excites me about this gathering is the commitment to rigorous scientific solutions for sustainable development, and that it is a conference by and for the African organizations, researchers, and their partners. I want to say that climate change as a movement got started in the science community. So as a result, we have all of the biases that come along with the who has a voice in science. So the research agenda hasn't always had an equitable and global lens. So I think this conference helps to set the agenda and helps to coordinate within the region. So thank you for the invitation to learn, listen, and support your work and stay involved with the excellent work that RCMRD does in the region. So next slide, please. What I will share is a little bit of how the Gates Foundation's agricultural development program is looking at data and decision systems for climate resilience. I'll touch on the latest science basis to frame the challenges, the latest evidence basis to help us understand what works. Quickly on the investment basis, because that's critical, how to scale solutions based on those building blocks, and some areas for data and decision systems that we're working on and ways we can accelerate our progress. I will say a bit less specifically about Earth observation and GIS, because the expertise in this across this gathering is much deeper than mine, and more about the areas that the development partners are thinking about applying some of those tools. Next slide, please. So quickly on the Gates Foundation and climate change, you probably haven't heard a strong voice from the foundation on climate change adaptation. And the foundation doesn't have a long history of investing in climate change outside of its long-standing R&D investments in improved crop and livestock genetics for stress tolerance. Its strong support of the CGIAR Global Research Consortium. However, Bill Gates became a co-chair of the Global Commission on Adaptation out of his deep concern about smallholder agriculture in places like Sub-Saharan Africa and South Asia, and the impacts of climate change on those populations. So since that engagement over the last few years, a strategy has been underway to increase the focus of the Foundation's agriculture portfolio on climate. So we've made a pivot toward a greater climate focus, and later this year, we hope to see additional support so that we can actually deepen our investment in our work across portfolios, livestock, R&D, gender, nutrition, digital farmer advisory services, agronomy, and more areas. So if you're not familiar with the Global Commission on Adaptation, it identified a number of priorities for action for smallholder agriculture. Those are listed there. And some of our priorities as we're thinking about this now within the foundation are these bullets on the right. So advancing next generation research and development, doing some of the things that other development partners may be less inclined to invest in, supporting more responsive and inclusive country systems, which we are all contributing toward, increasing efficient and sustainable use of land and water resources as those natural thresholds become more challenged. Increasing the delivery of timely, actionable information bundled with other inputs, services, et cetera, for early action on risks. I think that's a space that a lot of this community may work on. And then focusing on resilience and inclusion for the most vulnerable populations. Next slide, please. So I'll jump into the science basis quickly, which may have some common elements with other presentations this week, but this should come as no surprise, but climate change has already had dramatic effects on agriculture. We know that, we can see it, but this actually provides a sort of quantification of that impact. Despite major advancements in the last 60 years, this study showed that global farming productivity on average is 21% lower than it would have been without climate change, which has a huge impact on food security, on economic growth. We know other research validates just how much climate change reduces productivity from one year to the next. So 32 to 39% of observed yield variability for maize, rice, wheat, and soybean is due to climate factors. So it's consistent, from one year to the next. This is a big issue, the role of climate, and it has a huge impact over time. But if we look at the graphics, we see something else, which is that, in that red circle, that's the confidence intervals and the mean impact for Africa. And that is around 35%, that mean value. This shows you that the regions have not been affected equally, according to this research, by climate change. And on the right, you can see that in another way at the country level. Much of Africa is in the 25 to 40% range for the mean impact, meaning 25% to 40% lower agricultural productivity than we would have seen without climate change. So this is a strong headwind. Next slide, please. Also on the science basis, an important science-based goal for climate change is limiting warming to 1.5 or 2 degrees. So a few points on that. The first is we're already at 1.1 degrees warmer than historic average temperatures. This 1 degree warmer world is deeply challenging. Historic cyclones, the current drought, locust outbreaks, so many impacts that we can think of. That change of a degree took more than a century to warm, and we may see another 0.5 degree of warming in just 20 years. So that's a very rapid rate of change and a significant one. The second point is that 1.5 and 2 degrees are much different worlds. At 1.5 degrees, 14% of the global population will be exposed to heat waves every 1 in 5 years, according to the models. At 2 degrees, that more than doubles to 37%. In South Asia, at 2 degrees, I saw someone from Pakistan in the conference. The 2015 heat waves that killed thousands in South Asia could occur annually. So the third point is that 1.5 and 2 degrees are global average targets, and temperatures will not rise equally around the world. Now, everyone will not experience a 1.5 or 2 degree change if that's what we're able to limit warming to at a global average level. The figure on the right shows when 2 degrees will be exceeded under the RCP 8.5 high emissions scenario. And what it shows is by 2030, which feels like it's around the corner, 200 million people will live in areas that are 2 degrees warmer, $23 billion of production value. And in 2050, that's 1 billion people in sub-Saharan Africa. So, those targets imply that some regions will feel more warming than others, and sub-Saharan Africa will be one of them. A point about sort of what this sets up for us: if emissions peaked last year, the annual emissions reductions needed to limit warming to 2 degrees without negative emissions technologies would be a 5% annual decrease. So it will be hard to avoid either of these scenarios. Next slide. So this is a really different element of the science basis, which is about understanding land restoration, soils, and carbon. This is a very dynamic area of research, and our understanding of these issues is absolutely critical for growing more food without driving further land conversion, restoring and managing productive soils for adaptation and mitigation. So just a few points. I wish I had a nice summary graphic of the science here, but it's I think it's too dynamic, and we don't have all those answers yet. But models have underestimated the amount of carbon released from soils in a warming climate. Also, models that predict the GHG impacts of land management have been overly optimistic about soil carbon sequestration. So I think the science here is very active, but one thing that we do need is a more geographically specific set of analysis focused on land and soil restoration for sustainable food production, avoided degradation, and avoided carbon loss. The extra challenge is that as climate changes, the conditions for restoration and the conditions for soil carbon become more challenging. That warming only makes those challenges deeper. Next slide. So shifting now to the evidence basis. So that's a bit on, that sets up a little bit on what kinds of data and decision systems might be important for strengthening that science basis across the continent and the world. The evidence basis is just as important, which is understanding what works. So, these findings come from a small sample, but they're pretty interesting. I mentioned the Global Commission on Adaptation. There was a recent report called the Blueprint for Digital Climate-Informed Advisory Services, that's DCAS for short, and it identifies many challenges associated with digital climate advisory services, but also really strong returns on investment, an average of 1 to 24 cost to return ratio, 30% productivity increases for farmers accessing these advisory services, income improvements of 25% on average, and input efficiency gains as well. So the evidence around the potential for these solutions is very strong, which should lead us to, use this evidence to justify further investment, taking into account some of the challenges, and I'll mention some that they have found. And I'm sure this community has many more that they find in providing digital climate and other kinds of advisory, which is that there's a lack of consistent standards for validation of some of these tools, particularly challenging when climate data may be accessed or developed in different ways. Digital climate advisory services are not equitably accessible or usable by the communities who need them. There is still a supply-driven sort of marketplace around DCAS rather than more demand-driven and fit-for-purpose services. The timelines and budgets around some of these projects to support DCAS don't always accommodate financial sustainability planning, and there's a lack of digital readiness in many countries and communities that need these services most. And then two final points that they highlight. One is that providers are not always transparent about the processes, the partner roles, the uncertainties, the sponsorship arrangements or advertising that are involved, which can harm trust. And finally, the private sector is not often incentivized to engage in public-private partnerships. So I think this is a really important area for both sectors to look for more evidence around successful examples of public-private collaboration. Next slide, please. This is related, and again, on this point about what the value, what the demand for data and decision systems really is. This is about from the Series 2030 stock taking of evidence around what leads to adoption of adaptation practices in agriculture. And what this graphic on the right shows that information is key. Just having the availability of technologies alone was not as effective as this idea of bundling support around the adoption of technologies and practices. Nearly 50% of the studies on climate resilient crops identified extension services, which included information as the central component as a factor for successful adoption. So these in addition to finance tools and other enablers, but this just further reinforces the evidence around the work that many of you are doing to provide and disseminate information to the people who need it. It's an essential ingredient in promoting adoption of technologies, practices, and adaptation in agriculture. Next slide. So this is back to the sort of practices piece, which is the last element that I'll share. You move to the next slide for me. Our growing understanding of agricultural practices, their climate impacts, and their social and economic impacts. So one of the important, I think, shifts in some of the evidence research is not to think about a single outcome at a time, but rather how are we achieving multiple outcomes? How are we increasing yields, for example, increasing environmental benefits and sustainability, and ensuring that we understand the impacts of those practices on labor, on women's labor, on costs, on other considerations, the need for financing, et cetera. So this just shows a research where agricultural diversification, which is an important part of climate adaptation in many geographies, generally promotes crop yield improvements, generally promotes the provisioning of an ecosystem service, but it depends, and not always, and it depends on what kind of environmental and ecosystem benefit is being considered. So, the details are not as critical here. You can see crop yield response on the vertical axis and in ecosystem service response on the horizontal axis, and the distribution of those benefits. The point is that we need to understand these specifics in specific geographies in order to target investments effectively. So this really sets up what kind of data and decision systems can be helpful, geographically specific, with multi-dimensional analysis needed to prioritize and plan. So things like agroforestry, things like diversification, some of the solutions that might be under discussion in the adaptation and mitigation agenda, we really need to be sure that the productivity and socioeconomic dimensions are equally available to decision makers. So shifting now, next slide, please, away from the science basis, the evidence basis on solutions, just a quick comment on the investment basis, because those two pieces alone set us up, but the investment basis is how we scale solutions, either through public or through private channels. The headline here is that there are some fundamental gaps in climate adaptation. Climate mitigation is a decade ahead of where adaptation is, and a few categories in the analytics space, understanding what the specific climate and adaptation risks and opportunities are, where they are, when they're present, having that map, having those analytics widely available. Despite all of the progress that has been made, is still a gap. The familiarity of different communities and stakeholder groups with those analytics is also another piece. Measurement matters. And as you discussed yesterday, and I listened to some of those presentations, how do we measure both climate risks, climate mitigation and adaptation benefits, our goals? How do we know if what we're doing is working? What kind of data do we need to measure our progress? The third is investable products, services, solutions. How, what are the technologies, the software, the hardware, the practices that can, we don't have to have a custom, deep assessment every time to identify those. We know some of these solutions, and those can be more readily available for scaling. And then across all of them is data advisory, how we access the elements that we need to inform these on, a forward planning basis, on a real-time basis, and to look back on a historic basis. So that's all I'll say on the investment piece, but this has gaps as well that we need to look at. So I'll shift now, next slide, please, to some areas for focus. And again, these all touch on Earth observation and GIS solutions, but I'm remaining at this scale of what the development solutions require. So shift to the next slide for me, please. This is an example of integrating climate risk assessment into the commercial lending space. Can we get a next slide, facilitators? Thank you. For agriculture, small and medium scale enterprises, SMEs. So just a quick note, agricultural SMEs are part of this, what's called missing middle in many countries in terms of having access to financing, access to credit, which obviously is critical to making investments in adaptation and in building their businesses. And so it's a real hurdle for climate adaptation, is the ability of the agricultural supply chains and value chains to be able to invest more. So this is a project called Adapta, and it's a climate adaptation credit facility. What we're working on is the pilot phase, which will develop a credit and portfolio management process underpinned by a climate scoring tool to support borrowers in Kenya with their adaptation investments. So the simplicity here is that this commercial lending space lacks access to the data, the analysis, the Earth observation, and decision support that they need. It's very different from the world of data that the banking system uses. So you can see there are 3 stages of data coming in. One is an early review, which requires no field visit. It brings in remote data to get a basic climate score that helps a lender decide about whether or not to proceed. The second stage is more of a due diligence, which includes a combination of local, field data and other climate and remote data to develop what a climate adaptation plan might look like to manage risks more effectively and bring down the risk, to the lender, but also improve the return and profitability for the SME borrower. And then the third stage is portfolio management, which is, monitoring and managing the loans and the portfolio. So next slide, one more piece on Adapta. This is just to say that the trick is creating something that's easy to understand, really understanding what lenders need in order to manage this new information stream. How do we translate what climate risks look like in ways that help this community with those decisions that they face? So this is an example of what a dashboard might look like that gives decision relevant information. Am I looking at high, medium, or low here? And then this is that first phase illustration of what might be helpful. And then, how do we determine what possible interventions can help? So the value chains that we'll look at, that we plan at least to look at for piloting and testing this are replanting tea areas that are low productivity with more drought tolerant varieties, how to expand the sale of climate smart inputs to vegetable farmers, including greater availability of extension services and training. So these reach down to small scale producers. The entry point, however, is that lending facility that reaches the small and medium enterprises. And then working with mostly women poultry farmers with climate smart feed management, advisory, and other services. A second example, switching to the next slide for me, thanks, is integrating climate information and forecasts into agricultural risk management. So this is a project we're calling ClimArm, Climate Smart Ag Risk Management. The EFAD and a number of partners have supported this platform for agricultural risk management, or PARM project. And you can see an example of what the PARM analytics produced, which is an ag risk assessment and prioritization that's quantitative, but also quite easy to interpret and prioritize. So this looks at Ethiopia and ranks the relative importance of agricultural risks. Drought, livestock diseases and pests, plant diseases and pests, and price risks were the highest risk, the highest ranked risks according to this quantitative analysis. But what you see is a lot of climate related risks rank very highly in terms of the agricultural sector. So what we'll do by combining the expertise and the platform and the analytics that EFAD and PARM have supported in a couple of countries is bring in the expertise of the CGIAR, the CEOP partner in East Africa based in Kenya, to help identify analytical methods that will draw on the best expertise from those two fields. One being weather and climate forecast analysis, and the other being that ag risk management and ag risk management tools, ARM tools for short, to identify really what an investment blueprint would look like for delivering weather and climate services to support tools in this space. Now, those tools might include climate smart agricultural practices, diversification, extension services, advisory services, insurance products at a couple of scales, contract farming, commodity exchanges, even for larger scale risks. So the point here is, how do we go from pilots and one-off forecasts for, seasonal forecasts for farmers that may be made available to a more mainstream uptake of weather and climate information in the ag risk management space, so that we're bridging, we're not just speaking to climate experts, but we're also speaking to the ag sector. So this is one that's just getting started, but they intend to use as much efficient, remote data as possible, and really improve the resolution of the products that they have, but also make sure that they're available at the scale that can support those important investments that Ethiopia may be making, for example. Next slide, and my final slide on areas for focus. This gets back to that point of equitable leadership in the research agenda. So this gives a mapping, and I forgot the citation here. This was commissioned by the UK, and I don't know that it's been published yet, but this was a review of publications on agroecology and climate change. And what it does is map authors' affiliation countries and collaboration networks. Most authors' organizational affiliations are from the US and the EU in this subject area. Many links, though, you'll see within Eastern and Southern Africa, so that's a really positive spot. But the collaborations are mostly North-South and North-North, and there are fewer of those examples of in-region collaboration and connection. We want to invest in ways that will change the look of this map so that there are darker colors throughout the countries where these issues matter most, where the research needs to be generated, where the research needs to be exchanged. So we will look for ways to invest in the organizations and institutions that can raise the voice, the leadership, the evidence, and the research agendas for the continents that are facing some of these issues themselves. I will say Kenya is very active in this map, and that's a real bright spot to build on. So I'm closing now to the next slide. These are my very basic headlines, but as we look for ways to plug in Earth observation, GIS, and data and decision systems, on the science evidence side, climate change has present, significant, growing, and compounding impacts. Some of our models fail, I think, to capture that compound nature, and we need to improve the scientific understanding of many key systems and their interactions in particular. On the evidence side, many of the negative impacts of climate change can be prevented with the right set of actions. We have good evidence around some of those returns and benefits. And though we need more intentional data investments to monitor, to evaluate, to adjust and tailor those solutions. So we need these systems also to be applied to the evidence generation space around solutions. On investment, we know there are many cost-effective investments. They're not all cost-effective, but benefit cost ratios range, as we've seen some earlier examples, but they're largely very favorable. But in order to scale that investment, we need more climate analytics, more environment analytics, more products and services that are ready to go to support that investment environment. Finally, partnerships and collaboration are critical, and we probably are all saying this, but to bridging science, evidence, investment, and we need more engagement really across sectors, including economics, including public and private partners, including the financial sector, health, et cetera. So as we look at applications of these data and decision systems, how can we bring in more dimensions to what we study? So you're on the right slide. This is my last slide. I'm closing with something that Bill Gates wrote about a year ago about the climate crisis and the COVID crisis. And he compared the impacts of COVID with the impacts of climate change, warning that climate change could be much worse. The data has changed over that past year, but I think it's a really important warning for us, which is that we are facing a climate crisis, and we are living through and experiencing this global health crisis. We're seeing what it's like to quickly develop a science basis from epidemiology, the evidence basis from public health studies and tools, and the resources are available to act at a global scale. We've seen major financial packages come through, but we're not deploying these quickly enough, equitably enough, and we're not changing our behaviors. Adaptation is all about change, so it's going to be really important that we look at as many examples and models as we can. So in 2020, hunger shot up in absolute and proportional terms. More than a third of the global population of hungry people lives in Africa, and more than half live in Asia. The sharpest rise in hunger was in Africa, where the prevalence of undernourishment, 21% of the population, is more than double any other region. So that trend, that change, that increase is rather unthinkable in 2020 with all of the progress that has been made. So I hope we'll learn from the current public health crisis and the economic crisis that has resulted as we think about addressing the climate crisis, using our science, our evidence, mobilizing our investments, being supported by data and decision systems throughout, and working with those who embrace change and being willing ourselves to change. Thank you.
Thank you very much, Jenny, for that presentation. And I believe we've all heard a lot. It was quite deep, and we really enjoyed. We are going to put up the questions at the end of the three presentations. I also want to welcome those who may have joined us after we started. I think in our presence, we also have Mr. Claude Musabimana, Permanent Secretary in the Ministry of Agriculture, Rwanda. We welcome you and all the others who have joined us after we started this session. Now, going into the next speaker, it will be Mr. Meshach Kinyua-Nderito, Space Applications Training Officer at GIS in Africa, Department of Education, Science and Technology and Innovation at the African Union Commission, and who will be talking to us about Earth observation technologies for land degradation and deforestation monitoring. Welcome, Meshach.
Unmuting.
Unmuting. Can do it, you can do it. You can only ask.
Okay, thank you. Thank you. Thank you, Anastasia. Thank you, Jenny, for your presentation on climate change, and because these are two related issues, what I'm going to present and what you have already presented, I will probably skip most of the things and go directly to actually what we are also doing at the African Union Commission. So, Excellencies and ladies and gentlemen, my name is Meshach Kinyua. I'm the training officer for GMS in Africa, which is a project within the African Union Commission and under the African Space Program. And I'm going to brief you on it now. Back in 2013, I would just start by the background, then we go to what we are actually doing under the project. But we always like to present the fact that Earth observation is one of the integrated initiatives within the African Space Program. And how the African Space Program came to be is that the African heads of state and government, when they were transitioning from the Organization of African Union, OAU, to the current African Union, they had a sitting and they projected 50 years program on where they would like Africa to be. And that's a blueprint of what they would call the African Agenda 2063 from 2013. And when we look at the 7 aspirations of the Agenda 2063 and their different objectives, just like the SDGs that cannot be addressed without space components, the Agenda 2063 cannot be achieved without space. And hence, the African Outer Space Program was realized as a flagship of the Agenda 2063. And we have gone through a lot of processes over time. It started back in 2012, thereabout, and in 2016, we developed what we call the African Space Policy and Strategy, which is guiding the African Outer Space Program, and actually that formalized the program itself. And we're focusing on 4 main segments, which is Earth observation that we're addressing today, and satellite communication, navigation and positioning, as well as astronomy and space science. And out of that, we have created an institution which is called the African Space Agency, which is harmonizing and implementing some of the programs dealing with space in the continent. And we are still in the process of operationalization, but the agency seat will be in Cairo, Egypt. Now, what we also want to emphasize is that even though we have these 4 segments all together, but we know that the technology is converging quickly, and you cannot use one technology and ignore the other. As a matter of fact, when you want to apply things like Earth observation, probably you have to mix it with navigation and positioning and other areas of space. So they are integrated in a sense. So under the African Space Program, we have the Earth observation, and the reason for having the Earth observation is because as a continent, we realize how massive we are. And just to put a number on it is that Africa is the largest continent, the second largest continent, covering about 6% of the surface area of the Earth and 20% of its total land area, meaning that all the dry areas that or the land areas that are in the earth, Africa can contribute 20% of that. So we cannot trivialize the size. We cannot also trivialize the population, which is about over 1.2 billion with a high growth rate, and equivalent to about 16 or 17% of the total world population. And most of these are young people, which are meaning that we have a lot of skills that need to be developed. And we also have to tap into that demographic dividend. So the African continent is also home to world's largest forests. We have a lot of biodiversity on the continent, natural resources. As you know, we possess about 99% of world's chrome resources, 85% of platinum and others in abundance. But how we manage these resources, we require technologies that can really adapt and can give us more information than just observing on the surface. So Africans, enormous agricultural potential is also untapped, and it's huge, and we need to unlock that through the current technologies. So why we need EO is because if we were to derive information on all these parameters, we would probably take years and years to do that, and we would end up with errors. So we need technologies from above, and I would like to echo Socrates when he said that, a man must rise above the earth to the top of the atmosphere and beyond, for only thus will he fully understand the world in which he lives. In other words, we cannot fully understand the ecosystem and what is changing on the Earth's environment without having an observing system over us on the sky. And as you realize, with the satellite, you can cover huge areas and you can derive as many parameters as possible. In climate change, it's evident that most of the climate variables, or what we call the essential climate variables, cannot be realized without space. And this is quite important. And also in the land degradation, because we are dealing with huge ecosystems, we cannot rely on ground measurements alone. We need to be at a vantage height to observe what is going on and the changes thereabout. So as you know, the Earth observation, I cannot define it fully, but I can just say it's a system composed of series of satellites, as we know, a science component and data system supporting a long-term global Earth observation. As the Earth rotates, you are able to view different areas in different times, and you through that, you are able to see the changes. And we need that information for critical decision making. Data and information is therefore important, derived from these satellites, but we also need the in situ measurements, and combining both two, we can validate our measurements and we can have more, we can make more sense out of the data. So this an EO system is very vital for environmental management and providing information on adaptation, mitigation of climate change, as well as disaster management. While climate change and land degradation, we cannot dissociate the two, because it's either one leads to the other or the other way around. We have a lot of land degradation that has happened out of climate change, and climate change that has happened out of land degradation. So I would just talk briefly on what we are doing in the case of GMS in Africa, which is a project that we are implementing with the support from the European Union. And there is need for us to focus on the land degradation, because I was just looking at the figures. For example, on the Sahara Desert, from 1920 to current, it's encroaching the ecosystem, the savanna ecosystem, by 10%. Which is not good, meaning that we are losing more and more savanna vegetation out of, and the desert is encroaching. Not only that, we have a lot of forest that is being lost. The figures were leading on a study that was done in 2008. We had about 4 million hectares that had been lost already on forest cover. And this means that, humans are encroaching the forest regions, and they are destroying what could be the water catchment areas and what would, balance the ecosystem. So we are at a great danger. We are causing some of the issues that leads to the climate change that we are suffering, and we need to stop that, and we need to have measurements and data to do that. So in GMS in Africa, we are focusing on 4 main pillars, which is the data and infrastructure, getting to find out that data where it is and how we can apply it to our measurements. And then we have the products and services that we develop out of that. But then we have the support of the training and capacity building to make sure that the institutions and the people are well trained and they are well capable of producing those measurements and processing, as well as communication and awareness raising. And this is quite important because we need the policymakers and non-scientists to be involved. And if we keep communicating within our silos, we may not realize or we may not reach our goals. So we need to keep that communication and awareness going in order to integrate and to ensure that everyone is involved. We have a service we have 2 services. One is on marine and coastal area services. But I would like just to focus on the land, which is resonating with land degradation that we are dealing with today. We have 15 applications. We came up with 15 applications based on assessment that we did on different regions of the continent. We visited and consulted different institutions as well as different policymakers. And they gave us, the kind of applications that need to be developed to address their different issues. And you can see all of them here. I may not go through all of them, but within the presentation, I'm gonna come back to this. So we have, under the project, we have 12 institutions that are helping us to coordinate the project at the regional level. And we have 5 regions of the continent, which is the East, the West, the North, and the South, as well as the Central Africa. And in each of the region, we have 2 or 3 institutions that are leading projects. But altogether, we have a total of over 120 institutions that are working together in this entire project. And some of them are dealing with the marine areas, marine services, but most of them are actually dealing with the land services, which is quite important to highlight that most of the surface area of the continent is actually the land, and we need to know how to manage the resources and how to utilize the land resources that we have. So in Central, for example, we have 2 institutions that are dealing with the forest cover, and the 3 applications that we have here. We have GIS, which is the Gabonese Space Agency, and we are working with CICOS in Congo. They are dealing with the equatorial forest monitoring to provide accurate and periodical maps and information on forest cover change. They are particularly dealing with the Cuvette Central, which is the central point or the main origin of the Congo forest, which is huge and cutting across different countries. Is actually it's a huge study area, but they are focusing on a certain region, and then hopefully that within the next few years over the next projects, we can be able to increase that surface area which they are covering. And we have seasonal monitoring of wetlands areas, as well as providing an alert system on the deforestation, because it's quite important. As I said, we are losing a lot of forest within a short time, and we need to contain that. And most of them is coming from human interaction, and we need to assess that and also make sure that our people are well informed of the dangers. Then we have the monitoring of surface water quantity to provide daily information on water level and fluvial navigability. And some of these services that we are producing with these institutions are actually deployed. They are deployed on mobile phones to ensure that people have these kind of services at their hands. For example, then the fluvial navigability, it allows those who are using the rivers like River Congo to ensure that they have that surface on their mobile phones and to avoid obstacles and to avoid accidents that used to happen on that river. And through that, we are saving lives. It's a form of, it is helping a lot of community, especially the fishing community, to save more lives, and as well as the resources that they used to lose in the river. So in the South, we are working with one institution called SASCA, and we are developing a wetland assessment and monitoring platform for transboundary river basins in Southern Africa. And again, the main go for these services to ensure that the wetland are assessed and they're documented, and that we have a database that is more dynamic and it's accessible by all, to ensure that that information reaches the end users. And the end users may mean decision makers as well as public that needs to use this type of data. Well, in the East, we are working on different applications. We have monitoring of natural resources and food security. We're developing data and information services for natural habitats, monitoring and assessment. We're looking at tropical forest surveillance and assessment, as well as seasonal and monthly crop conditions and monitoring products, crop yields, and so on to inform the food security component. We're also looking at land degradation monitoring and assessment, wetlands monitoring and assessment, and having an open geographical regional reference vector database. Well, we're working with institutions, we're working with RCMRD as one of the leads, dealing with the last three. And we also have ICPAC, which is an IGAD institution, dealing with the first four. We have reached a lot of milestones through these projects, and again, looking at deploying these services on mobile phones, as well as that is on top of the traditional geoportals, because we realize that geoportals are more, scientists are more convenient with geoportals, but when you talk to the end users or the policymakers or people that need to use that data regularly, probably you need to take them out of the geoportal to the mobile phones, and this is one of the things that we are realizing in this project, and it has been happening in different institutions. Well, in the West African region, we are working with two institutions there on land degradation, and one of them is dealing with sustainable wetland management for enhancing food security. That is Centre de Suivi Ecologie in Senegal, and we're working with the CSSTE in Nigeria, which is we are producing a regional flood database to enhance the efficiency of DRR and flood monitoring, again, ensuring that we have a dynamic database that is available to users and that is accessible for all, and they can develop further services out of that. In the North, we're working with one institution called OSS in Tunisia, and we're looking at sustainable management of land and water, generating data and information out of the satellite data, as well as in situ information, and mapping and evaluating irrigated areas and characterizing and monitoring the land degradation, especially agricultural areas and water catchment areas. So as you can see, we have a lot of applications that are distributed within the continent, and the main goal is to ensure that we have that kind of synergy between all these projects, and at the end of the day, we hope to have a continental service of land degradation or land service, what we call the land service, which is water and natural resource management service. And out of all that, you realize that most of these applications are actually in the need for early warning systems, where we cannot, for example, deal with floods, we cannot deal with land degradation without proper early warning systems. And these are some of the challenges that we have realized within the project, that actually at observation, we need to work more on the models. We need to work more on accessible real-time data in order for us to have that particular early warning system that can help us, warn the communities as well as decision makers on where to go. So I'll talk more on the opportunities and challenges that are at hand. One is that because we are dealing with a lot of applications, we are dealing with huge surface area or regions of interest. We need a lot of bandwidth around that, and as you know, the continent is not well versed with. It's not ready yet for huge downloads of information because of the internet bandwidth. But progress has been made, although we need to do more on in terms of increasing that internet bandwidth. But we look forward to this map that, by 2025, the internet contribution to the GDP will be in the billions of dollars, meaning that we'll have more penetration. We will have more internet users, meaning that we have good or better bandwidth than we have today. And we will have a lot of services being developed over the internet. And Earth observation cannot be dissociated once again from the internet services, because we're dealing with huge amount of data that needs to be moved from one place to the other. Most of this information is either available on the internet if you don't have direct downloads from the satellite themselves. Now in GMS in Africa, we have a system called UMETCAST system, or the E-Station, which is actually giving us the privilege to have real-time access to information or from the satellite data from the Copernicus or the Sentinel satellites. And then through that, we are able to push some of the services through that system. It's internet free. We don't need internet, but sometimes when there is a gap, you still need that internet to download your information and process it. So we're also taking advantage of the new space. As you know, over the last decade, we have seen a lot of countries that are launching satellites in space. They have caught the interest of going to space now. And that's because of the affordability, as well as the leanness that is there in the space nowadays. The new space component, it's not like it used to be like 10, 20 years ago. We have more access, we have less expensive, ways of reaching to space. And this is calling us not only to focus on the downstream sector, but we need also to focus on the upstream in terms of accessing space, because if you need real-time data, you cannot avoid to have your own or to develop your own space segment system that needs to supply that data. And I think it's important for Africa also to be in the forefront or in the race of space, so to say, in order for them to acquire that technology, as well as to ensure that the data can be freely available, or they can be frequently available as much as they can. And with the small satellite industry that is developing nowadays, we have CubeSats that are doing a lot of rapid mapping. If you deploy a lot of them, they can be useful for the continent, especially when we are dealing with services like land degradation, when we are dealing with disasters. We cannot, avoid to be shy or, avoid to be in this market. So the opportunities there for the new space we can take advantage of that. One other thing that we are realizing is the digital Earth through cloud computing. This is one of the things that we have been using in the project, cloud computing, allowing us to download only the necessary data and free the bandwidth, because we don't have enough bandwidth, especially in some regions. And if that is a challenge, it delays a lot of downloads or a lot of information access. But with the cloud computing component, it's possible to develop your algorithms and deploy them in the cloud and only download what you need. So this is an advantage, and it's an opportunity that we should take advantage of. We also have terrestrial connectivities increasing nowadays to provide us with more access to data. Then we have increasing availability of digital Earth and data services. We have many system of systems. We have the Copernicus system, we have the MTG, and many others that cannot be listed here. So the issue is not the data itself, but it's the accessibility and how to get it in the right place and how to choose it rightly and combine it in the right manner. And I think this is the call for the scientists to take advantage of that and to know how to combine these data sets and to ensure that the information being derived is more enhanced. So we're also having a growing industry in the satellite market. In Africa, as I said, by 2019, we had about 35 satellites, and this far, I think we have more than 40 now in space. Most of them are, of course, scientific satellites that are for research activities. They are small satellites. But as you see in the ranking, we have 14 Earth observation, probably more now because we have had more countries launch the satellites. And that is to tell you the demand for Earth observation. Apart from communication services that we need in the continent, I think Earth observation is the most relevant discipline of space in the continent because of the huge amount of resources that we have and we need to manage from space and using other technologies. So by 2024, it's predicted that at least 15 countries would have launched at least one satellite into space, operational satellites, of course, not test satellites. And by 2024, African countries would have launched about 64 satellites in space. Well, that is an opportunity for countries to collaborate, especially in deploying some of these missions to ensure that this data can be enhanced, not only to duplicate efforts in space, but to ensure that launching of these satellites can be done in tandem, so that each country is able to use the fellow countries' data, and they can do that to ensure that we have a system over the continent that covers the entire continent and provides information to everyone who needs it. So African space industry is also currently worth $7.37 billion, and we expect that to increase to about more than 10 by 2024. This is a study that was done by Space in Africa, and we still have kind of unbalanced expenditures that we need to balance in terms of contributing to the digital wealth and to our digital services. Well, we are creating more employment in the space industry, but we also need to make sure that the downstream sector, the realization of that data to derive useful services on the continent is more emphasized, because it's not only a matter of going to space, but the most important thing is to make use of that data and to derive the useful services. So the challenges that we have, of course, I mentioned some of them. We need to intensify the connectivities. The bandwidth is an issue that we cannot run away from. We need to intensify that connectivity. We also need to have more, human capital development. As a matter of fact, the African Space Strategy identified that we need to, keep on training people, people in different domains to ensure that we have a critical mass that can support the African outer space program that we envisage. So lack of funding is always a challenge, but I think this can be overcome by the recommendation that I'm going to say here for the need of synergies, because we are seeing a lot of duplication of efforts in many of these countries or in many regions. We have a lot of projects that are probably dealing with the same thing. We have institutions, we have initiatives, we have industries that can be mobilized. But it would work better if we can synergize all these activities or all these initiatives together to derive a more impactful service for the continent. And through that, we conserve or we preserve some of the resources for investment on the other areas. And I think this is what we're emphasizing with the GMS in Africa phase 2, because we are coming to the end of the phase 1 now, but in the phase 2, we are focusing more on the synergies, what can be to have that an interactive platform between different initiatives to ensure that all the services are developed optimally, and we have services reaching either the decision makers or the end users conveniently and at the optimal level. So I will stop here for now, knowing that we will have some session of discussion. So I don't want to take your time. I'll wait for more questions when we get to the discussions.
Thank you very much, Meshach. That was a very interesting, very enlightening presentation, and thanks for letting us know all that you're doing at the AUC and the GMS in Africa project. As you say, we will have some discussions at the end of the presentations. And I want to take this opportunity to also welcome those who may have joined us after we started. We are having this keynote session of the day. We've already had one speaker, Jenny, and we just finished listening to Meshach. And before we go to the next speaker, Dr. Macharia, I want to recognize some of our key supporters and stakeholders and people we work with. who have joined us after we started. Andre Nogumana of UNECA, thank you very much for joining us. He was with us yesterday as one of the guests. Dan Awin of NASA, Steve Ramage was one of our key speakers yesterday. And Dr. Hussein Farah, our former Director General, welcome. Claudia Capitani from EU-JRC, and Michael Gould of ESRI. And every other participant that is listening to us, we welcome you very much and we're happy to have you. And now we move on to the next speaker of this keynote session, who is Dr. Peter Macharia. Dr. Macharia is a postdoc researcher on spatial epidemiology at the Center of Health Informatics and Computing and Statistics at Lancaster University, UK, and also at the Kemri Wellcome Trust Research Program. Welcome very much, Dr. Macharia.
Thank you, Anastasia, for the introduction. I hope you can see my slides.
Yes.
Thank you for confirming. So I'm going to take a different angle, slightly different angle from the other speakers. I'm a researcher. I did a lot with spatial epidemiology. And in this talk, I'm going to give an overview of how we use GIS and Earth observation when we are dealing with health-related challenges. That will be the talk that I'm going to give today, so slightly different from what the others have given, but what they have talked gives an indication of what we can derive from other observation. So they always say that a picture is worth 1,000 words. So my talk will be more graphic, less words, just a disclaimer to note. And to start with, there has been an increased interest on climate and health. The graph that I show on this slide here shows the research that has been done on climate and health over the years. You can see where we were at in 2013, and by 2019, there has been a lot of publications coming up just talking about climate and health. But if we go deeper and try to understand what those researches are about, majority of them are talking about the impact of climate on health and less talking about adaptation and mitigation. And from where these research articles are coming from, we have few from Africa, but majority from Asia and somewhat from North America. And you can see there is also disproportionate distribution when you look at low and lower middle income and high income countries. So the low and lower middle income countries, also we have less coming from here. But what I'm getting from this is that there is an increased interest on people wanting to know the impact of climate on health, and less on adaptation and mitigation, something that probably we should start to think about. And if you look at where we are as Africa, we are not doing as good relative to the other regions. So geographically, these are where the studies are coming from, for where they had geospatial data to geolocate a point. So you can see in Africa, we have a bit in West Africa and East Africa, a bit on this southeast part, less on Central and North Africa. What these papers are talking about, or what these research articles are talking about in Africa, so they are talking mainly on climate change, climate variability, and weather. That's the first domain that those articles are focusing on. And here they are thinking about rainfall, general climate change, and seasonality. And the health impacts that they are looking at, they are especially infectious disease, public health, and malaria. I work a lot in malaria, and most of the examples that I'm going to give today will be in infectious diseases and in malaria. And when they think about how this climate change or variability is impacting health, the mediating pathway are through households, age and sex, and social vulnerability. And the options that are being talked about for responses include disaster reduction, disaster risk reduction, greenhouse pathways, and energy policies. Just to give a very broad overview, on one side, we have the health sector. And I think the overarching goal here is very well summarized in SDG number 3, that we all want good health and well-being. But we have issues that are related to climate change and variability that are related to health that might be a stumbling block for us to achieve the good health and well-being that is articulated in SDG number 3. And on one side, we have Earth observation and the data that it has been giving us and the potential it has to give us even more data. Then we have GIS and all its spatial analytics capability that it can. In between these two, we have a range of things that are related to health that we can utilize these two here, Earth observation and GIS, to help us solve, to help us get good health and well-being. So one could be support for responses. And in here, I'll talk about an example, disease mapping, future projections. This is especially important when we want to know what will be in 2030 or 2050, disease-wise, if you factor in climate change or variability. Then also looking at environmental suitability of negated tropic diseases. We have early warning system, child survival, and health. So this is just a simple summary of how this would intersect health, climate, and what we have that we can use to make our lives better, or better health and well-being. Going to the first example on how we are using these GIS tools and EO Earth observation to support response. So I'll give an example that we are all aware of. We know what happened in Mozambique in 2019. We had these two cyclones. It was all over the news, and the impact was quite huge, negative impact. We had deaths, injuries, a lot of people in need of humanitarian assistance. We had so many communities that were isolated from healthcare and many other things that they do on their day-to-day lives. Telecommunications destroyed, road connection damaged, then very limited access to safe water and sanitation, a lot of overcrowding in the temporary accommodation that was given in these regions. Then we had outbreak of diseases such as cholera. Then there was a surge in malaria cases. When you look at this situation that has been brought about by probably a change in the climate, how would GIS and Earth observation helped us in this case? So I pick an example of a paper that was done and published recently in BMJ. They tried to look at how these cyclones affected access to healthcare. So what was the situation before the cyclones and the situation after? So, and this is very important as it might help those who are responding to know who is marginalized, who needs what, where, and when. So EO came in handy here, data on land use, land cover. Then very important were the flood extents, which regions had been affected. Also important were to know the population data, population distribution in that region, so that we know a certain region that has a very high population density has been affected. And we know that there are so many groups that have been modeling population density, such as Facebook Connectivity Lab. We have SciSen, and key to this, they use land cover to disaggregate their data. So you have data at a regional level, say at county, and you want it at very high resolution, say 100 by 100 meters, and you need land cover so that you can disaggregate people from the unlikely areas. We know people do not live on rivers, forests. We know they are likely to be where buildings are. So here a model was done using GIS tools, and these were some of the results. So the map on A shows access or travel time to health facilities within 2 hours before the disaster came. Then B shows what was the situation after the disaster. So you can see the red areas have quite increased in large numbers. And just to quantify in terms of population for the under 5, who are the most affected when such disasters strike. So we had access reducing from 78 to 52% as a result of this disaster here in the first cyclone Idai that came. And we had about 137 under 5 children not being able to reach the nearest facility within 2 hours. Then the other one, the Kenneth one, the reduction in access, or those who are able to access the nearest facility within 2 hours, reduced from 82 to 71%, meaning we had about 14,300 under 5s not being able to access care within 2 hours. So this is some important information that could not have been derived if we didn't have other observation on our side and we didn't have these GIS capabilities to help us respond to these disasters that have come as a result of probably climate change that can help save lives. Now, I'll go to the next theme that I want to give an idea of: disease mapping. So we have so many health outcomes, and we want to understand their distribution in space and in time at very high resolution. So how does climate come in here, GIS and other observation? So normally what we want is, we have sampled, this is an example of Uganda. You've sampled so many villages in Uganda and surveyed and examined if they have malaria. So if they have the Plasmodium falciparum that causes a majority of malaria cases in Africa. And you want to end up with a continuous map on the other side so that you can do the distribution of these disease. So here, environmental factors have to come in because they affect the dynamics of the vectors and parasite. So there is some good temperature or some suitable temperature or rainfall where the vector here, the Anopheles mosquito, or the parasite, the Plasmodium, will do better. So we need to incorporate this when we are doing these predictions. And they also assist us where we have not sampled and we need to get an idea about it. So if you get the relationship between these environmental covariates and the disease that you've observed, you can use that to extrapolate in areas where you had not observed your data. And also mathematically, it assists very much in fitting a model that is not as much as complicated if you didn't have these environmental factors. So a range of them that we've used in the past, we have, for example, rainfall, which shows the suitable breeding sites or vegetation indices. We have temperature. We have a range of temperature that is suitable for survival and development of these parasites or vectors. And any change on this temperature over time will definitely impact the distribution of these diseases. We also have things like nighttime lights, humidity, wind, land cover that we all get from Earth observation. So when you bring in these environmental factors and fit a geostatistical model where you are saying that the probability in a certain location X, one has the disease of interest, is a factor of these so many covariates, which if change over time, they are going to affect the distribution of diseases that we are seeing in different localities. And also you have to incorporate space, because we know that things that are close in space are more related than those that are far apart, and an element of error needs to be included in this model. The same would apply if we want to do this in time. So instead of having xi, you can add an element of time so that we can say in space x, time t, this is what you are observing. And this has been very instrumental. I've been involved in several projects where we are working with national malaria control programs, doing such work across Africa and helping them shape their decision on to how they are going to control malaria. And it has also been applied in other diseases, not necessarily malaria. My examples are more malaria because that's my domain. Here I'm going to show future projections. And again, I'm going to show an example of malaria cases. So this is the current situation of malaria prevalence globally. This is 2017 that I'm calling current. This is how things look like in 2017, or how they looked like. However, we want to understand what would be the case in 2030 and in 2050, so that we can prepare and be ready for what might come. So what we do in such situations, or what the commission that is looking on malaria eradication that has been doing in this work that was published not long ago. So you want to capture the association between malaria and these covariates that we talked about in the previous slides. So it could be temperature, it could be rainfall, it could be humidity, and socioeconomic factors, for example, maybe proxied by nighttime lights. Then you want also to project your covariates to know how they will look like in 2030. How will temperature look in 2030? How will temperature look in 2050? So if you combine the association that you are getting between environmental covariates and malaria data you've observed from villages and communities and hospitals, you can estimate the future prevalence given the changes that we've observed in the climate over time. So if it's an element of rainfall that has changed, how will it be in 2030, and how has it affected the prevalence of malaria in 2030? We can also add another layer of control interventions, something to do with bed nets, indoor residue spraying, or effective drugs like ACTs that are used for malaria. So if you bring those into the mix and bring these future scenarios for climate, how will disease look like in 2030 and 2050? And are we likely to be able to eradicate the disease by then, or what will be the situation by then? So this is a map of 2030 showing if we have the change in the covariates that were used here, the environmental covariates, and you let the interventions remain as they were, how would prevalence look like in 2030 here? So you can see not a lot of changes with this current map, but the areas where you have red has slightly reduced. But if you go a step further, so climate changes up to 2050, the way it will change, and we improve the intervention coverages. So to the year optimal, maybe bed net coverage goes to 80% in the community. We do a lot of indoor residue spraying for the houses. We have effective drugs. The situation will be better than it would be if we didn't change our intervention coverage, and given the trends that we are observing in climate. So I want to go to another area where these technologies are being applied, and this is neglected tropical diseases. They are mapping and setting priority areas and knowing the endemicity of these diseases, because in the first place, these have been neglected. And if they have been neglected, we need to start knowing what are the priority areas, what are the endemicities of these diseases, so that we can intervene on these areas and prioritize. And this is very in line with the SDG fundamental principles, that we need to know who are left behind, who are the farthest, and reach to those who are the farthest first, so that they can catch up with the rest of the region. So looking at one of the NTDs, podoconiosis, some might have come across it, but you can see the effects are not as interesting here. These are photos taken from a publication, and there was informed consent by the users who gave these photos. And you can see there is a swelling on the lower legs and feet, and it is common among those who walk barefoot and in contact with volcanic irritant soils. And this brings about a social and economic burden. So it's better that if we need to implement some prevention or management strategies, where is the disease endemic? What are the priority areas that we can focus on? So just to give an example, this is here combining a suite of environmental factors at a certain time points, say for example, elevation, annual precipitation, land surface temperature, vegetation index, soil characteristics, and some presence and absence data of this condition, and seeing where is it suitable that this disease will do well, so that we can focus on this area. And the map shows that suitability range from 0 to 1. So the more the red, the more suitable that area might support this disease, meaning that if you went to that village in that locality, it is likely that you might meet somebody who has this health outcome. And if you look at the predicted suitability here, the most suitable, depending on a certain threshold, these are these red areas across sub-Saharan Africa. So you can think of how would also this map change if climatic conditions change over years and over time. Another interesting area is early warning systems. So if there will be a surge in malaria cases in a certain region, some national malaria control program wants to know. Probably it's because rainfall have been higher, temperatures have changed, or breeding sites have changed because of a certain environmental condition changing. So this is what such bodies would want to know. Also, say for example, if a certain condition has changed, probably in that area, mosquitoes will do well than they were doing before. And just to give an example of work that was done by microbiologists sometimes before, this is in Mozambique. They made an early warning system, and they were trying to look at what is the probability that a certain threshold will be reached within a certain district. So say, for example, we know that if we get 1 case per 1,000 people, that's a normal situation. But if you get 5, there is cause of alarm. So then we need to set up a system that can tell us, okay, in this district, we are starting to have spikes and probably we need to prepare better. But for you to do that, you need to get malaria incidence data. Then you need to get a range of environmental conditions here, like rainfall, temperature, humidity, barometric pressure, saturation vapor pressure, and apply these within a model so that you'll know with what probability a certain district will exceed what has normally been observed. So this is week 1 in 2017 in this country here. So the incidence is per 1,000. So this is what has been mapped under 7 up to over 31 in the red areas. The map on the right side shows what are the areas that are likely to get spikes for the set threshold and with what probability. So the red area says if you set an incidence of 2 per 1,000, you have 80% confidence that these areas are probably experiencing a certain surge. And the government of the day or the control program in that area needs to move in that area. And if it's a foci, deal with it immediately before it can spread outwards. You can do this for malaria and you can do for any other tropical diseases. The final example that I want to give is impact on child survival. Here there is a study that was done recently, and it tried to show pathways through which changes in climate are impacting child survival. So you have, for example, greenhouse gas emissions, and these will trigger some climate change in several ways. For example, extreme weather, altered rainfall, you have raised temperatures, sea level will rise, acidification of the oceans. Then this is going to have some direct and indirect effects to the health of our children. So for example, the direct effects are the changes in temperature, precipitation and floods. We have droughts and wildfires. And the indirect system here are like changes in the ecosystem, changing vector pattern. Then how does this now affect the health? So you have food insecurity and malnutrition. Education attainment is affected. You have forced migration that you not have wanted. But then how do we then observe these within our health systems? So you have mortality and morbidity due to these extreme weather events on this side. So for example, infectious diseases changes, just for example, the examples that I've given, you have water and foodborne diseases, you have respiratory pathogens, mental health, and such other examples. And one example that was given in Uganda, they were looking at the effect of climate change on malaria incidence over time between 2013 and 2017. So if you control for the normal things that we know affect malaria, for example, intervention coverage, socioeconomic sector, status, health-seeking behavior, what would be the effect of rainfall, temperature, vegetation indices, land cover, distance to water bodies over this time. One of the summaries that was given in this paper was some of these factors contributed to more favorable environmental condition for the transmission of malaria. And this has detrimental effect because we want to lower malaria. That's why we are having all these interventions. We are encouraging people to seek care. But on the other hand, due to the changes in climate, it is creating more favorable conditions for vectors and parasites to do better, and it is negating our efforts. And the recommendation that was made here is an early warning system, just like the one that I've described, would be important for the program so that they can know when a spike is on the way or a spike is coming up. And just to wrap these up, these are quotes that I took from these other observations in support of the 2030 agenda for SDGs. So the government's industry currently have realized that EO has some substantial part to play in climate change and in health. And we should continually do all we can. And as we have seen, Africa is quite lagging behind in terms of the work that is being done in climate in health. And rather than just look at the impact, also try to see how we can adapt and mitigate. I'm going to end at this point and take it back to Anastasia. Thank you.
Thank you very much, Dr. Macharia. Very insightful presentation. And I think at this point, we are at the end of the three speakers. Thank you very much. We've heard from you. There are some questions that have been asked by the audience in the question and answer session. There are some that are being answered there, but there are still others that I will just post to you in the few minutes that are remaining. And I hope we shall be able to address all of them, hopefully. My first question goes to Jenny. There are two questions for her, and I'll just go one by one person. One of the questions is, policy simulations are critical to directing and informing policy agenda, more so drawing on a systems approach when handling complex borderless challenges, such as climate change. How far or to what extent has this research series, the one that you presented, been benefited from systems thinking and system dynamic models? And the second one, I hope you can, you'll be able to answer both of them quite fast, is you talked about the importance of measurement. How can the monitoring and assessment of food security and agriculture in the face of climate change be harmonized, considering the differences in units of measures, that is spatial and non-spatial data? And these are, I don't know, I hope you're jotting them down just in case. This should be one. Someone from Djibouti is asking whether it's possible for Djibouti to be integrated into the pilot country in the CLIM ARM project that you presented. So Jenny, if you can answer those questions, will be very appreciative. Thank you. Welcome.
Thank you for those. Thank you for those questions. On the systems modeling question, there is a lot of work that one thing we're working on is with IFPRI and some other partners is how to better include climate in some of the agricultural models and economic models. So yes, that work is being done. It has some very interesting potential systems findings, like, you know, what happens if different policy levers are utilized. So I think it's a really important area for further work and modeling improvement. So yes, there's some. I don't have publications to share at the moment, but I could forward what is available when we have it. On the question of measurement, I actually did type an answer into the Q&A box. It's a really good and very challenging question, and adaptation just struggles with the fact that it is so place-based. It is so context-specific, and there isn't a single metric like greenhouse gas emissions that we can use. But I think there are a lot of things that we do measure that are very relevant. Things like productivity, land cover, water resources, NDVI, pest and disease impacts. Those things we are climate sensitive. And so measuring them will help us understand climate adaptation in the agriculture sector. And there are ways that we can analyze those data that provide insights about adaptation. Are we seeing trends? Are we seeing volatility? Can we kind of account for climate shocks and stresses and seeing how those things react? Would we have expected a greater decline in some of those variables without adaptation? So some analytical questions. And then I pointed to a couple of resources. One is the International Platform on Adaptation Metrics, has a subcommittee on agriculture that's working on this topic. And the CGIAR CCAF's Climate Change, Agriculture, and Food Security Program did a stock taking of adaptation metrics. That really just collects all of the metrics that are being used. And it's not specific to remote sensing solutions, but I think you would maybe find some interesting pieces there. And then when we get to adaptation, not just monitoring sort of climate impacts, there is a diversity that's challenging, but perhaps we can standardize ways that we monitor and measure different adaptation solutions in different farming systems. So that's a really important area. And then on the question of joining the ClimArm project, we haven't even started. We're just getting going, but we will start with a pilot in 2 countries. But my hope is that that is something that will be much more widely relevant to a lot of countries. And one way that we can support that scaling or replication of that kind of investment is by engaging a lot of development partners in what we're doing, so that if there is interest and demand, either we can support that scaling or other partners can. So thank you for raising that and your interest in that, and stay tuned. We're just starting. Thanks.
Thank you very much, Jenny. I think the next question goes to Mijak. The next question goes to Mijak, and there is a question on the progress of land degradation. I know you tried to answer it in the question and answer on how this work can be accessed by other users, and also how this work is informed by other work such as ICRAF, this HAVA project, and Conservation International, and also the need to avoid duplication, but also have products that are site or context specific. How do we create such a balance? Misha.
Yeah, thank you, Anastasia. Thank you. I tried to answer the question on the chat, but I can repeat it here. So what we have is, we have regional focus projects, and as I presented, there in the 5 regions of the continent, each one dealing with probably similar or dissimilar applications that are addressing the land degradation or the land service, as well as the marine and coastal area service. It's possible that in this project that they have already integrated the works that are being done by other projects within that region. It's difficult to say if that has been done, because we have not closed the project to see all the assessment that have been done yet. But at the end of this year, we should have a full assessment of the land degradation, at least in the 5 regions of the continent, being drawn from different applications. Some are looking at the wetland database, some are looking at directly on the protected areas, some are looking at forest and forest cover change. Well, if we integrate all these applications, we'll be able to have that assessment that is context specific. And as I said, we are looking at synergizing for the mere fact that some of the background work has already been done through other projects, and we need not to duplicate efforts. And that's the message that we preached when we started the project, that interact with others as much as possible to ensure that you don't have to redo the wheel or to redo the work that has been done already. But in doing so, also look at how to validate it further and to add value to what is existing. And that's why we did not throw away the previous projects. You already know that we had a project like MESA. Some of you are already familiar with the project of MESA, which is monitoring of environment and security in Africa, which concluded before GMS came in. So we took all that data and we built on it. And most of the projects that are being done at the regional level are taking that advantage. So I know that some of them are interacting with other programs, and we have done a lot of connecting the dots with other projects at our level at the AUC. By pointing them to the most relevant people at the regional levels in those projects. I don't know if it's answered.
Yeah, I think if there's a clarification, I'm sure we should be able to follow you up. My next question goes to Dr. Macharia, and there are two questions here. One is that Africa is still struggling with malaria decades after it was controlled in other parts of the world. What is being done in terms of prevention? If you have come across any of those, you can enlighten us. And also, in relation to that, to what extent has this research that you have shared with us been used in informing policy decisions, e.g. health agencies, so that they are able to prevent or mitigate these climate-related diseases? Dr. Macharia.
Thanks, Anastasia, for those two questions. I'll start with the first one on what Africa, or why there is still malaria in Africa, and it is a complex question. So, but the first one, I think, is because of resistance that has been witnessed and was witnessed several years ago. Then number two is that the development of a vaccine has been elusive for several reasons, but the main one is because of how the host, the vector, and the parasite interact. But we are doing well in that front. Currently, there is vaccine pilot projects that are ongoing here in Kenya and 2 other African countries. So in the western side of Kenya, children under 5 are being vaccinated from a malaria vaccine that is under a pilot implementation. And so far, the results seems to be promising. So I think that's a positive thing. Then we are trying to have new set of control measures rather than the ones that have been used. So just trying to bring in other tools to fight this disease. Then the other question, if what I've presented has been used. Yes, I've been part of work across Africa where we interact with national malaria control programs, share with them the results that we have on how they can better do subnational stratification, because we know malaria is not equal within a country. So in region A, they can apply this, region B, they can apply this, given the malaria prevalence in that region. Yeah, so I'm a witness that these results have been used in some of the countries here in Africa. Thank you.
Thank you very much. I think the next question is for Jenny, and you presented a very great research, and there are several phases where you talked about moving from science, evidence, and investment. And has there been use of in situ data in any of those studies, if you're aware of that? And what is the level of openness of the data that has been used to enable other users make use of the results that you have, or enable them also do assessments within their regions? Thank you.
So Anastasia, is that a question about some of the research that I shared, whether that data is it openly available?
Yes, whether it's openly available, and if you're aware whether there is any in situ data that has been used to complement any of Earth observation assessments.
Yeah, a lot of the research some of the research that I shared was meta-analysis or literature review, and so it comes from a very diverse sort of base of research. I'll have to look at the specifics. I don't know, I don't have off the top of my head that answer, but I would actually point you to a project called Enabling Crop Analytics at Scale, which the URL is cropanalytics.net, which is an effort to improve the availability of ground truth data for more Earth observation and AI applications. And I'll also put a link to one of the other questions that came up. Let me see if I can just look at it quickly, which was about the rising nature of spatial data providers and criteria designed to guide and measure the accuracy and reliability of that data. And I think that ground truthing is certainly a huge element of that. And I'm very interested, whether it's for spatial data or other data, how its users and its audiences can have a better, can trust in the accuracy that they're provided. So WMO is an authority on weather and climate data standards, but for spatial data, I would look more to GEO and other groups that work specifically on that spatial data piece. I hope that was helpful. If there are any specifics, people can follow up on the specific research, and I should have all the links in my slides.
Thank you. That would be very helpful, because there was someone else who was asking where they can get more materials or documentation on what you presented. So that would be very helpful. Thank you. I just have one question for Meshach, and given that AUC has a continental reach within Africa, are there coordination efforts, given the possibility of similarity of activities by other agencies, especially in other countries in Africa, in land degradation and deforestation monitoring, so as to avoid duplication efforts? I know you mentioned about building up on what others have already done so that you don't repeat the same, but is there a sort of coordination among the agencies that AUC is involved in or spearheading, so as to bring the synergies and avoid duplication? Meshach.
Okay, thank you. Thank you, Anastasia. We work with our sister department because we lead the science component, which is the space applications and the space program. But there's a sister department which is called Rural Development, and it's called DREA. So that department deals with the climate change issues at the applications level, and then we provide the scientific context. And they have a coordination together with the UN institutions that are dealing with specific issues like drought and disasters and climate change. And so we work in tandem with them. So in terms of coordination, yes, there's a mechanism that is available at the African Union Commission level. And what I can do is I will locate the person that is asking the question, and probably I can refer them to the appropriate person that deals with that coordination mechanism.
Thank you, Meshach. And this is the last question I have for Dr. Macharia. And the question is if there are opportunities for replication or upscaling of the research that you have presented. I don't know if you heard me, Dr. Macharia. The last question for you. Are there opportunities that you may have identified for replication and upscaling of the research that you have presented to us today?
Yes, there are more opportunities to extend what we've already done. So many groups across the globe are doing malaria mapping and disease mapping. So the first point would be like to review what those are doing and see what are the deficiencies or the research gaps that can be done. For example, one of the things that we are doing currently is to create a user-friendly application where the national malaria control programs themselves can map them already on their own without having to use these complicated programming languages platform. So yeah, there are many areas that we can extend to make this disease mapping space better.
Thank you very much. That was a very informative session. Unfortunately, we cannot go on because our time is almost up. And I really appreciate the engagement of the participants. It's very engaging. They've asked a lot of questions, and please, using our app, the Hubilo app, please log in. You should be able to follow up with the speakers and ask them more questions and get more engaged. Now, I again want to recognize the participants. Thank you very much for being with us. We have participants from around the globe. From Peru, I can see someone from Peru, Antonio Arroyo. We have Singapore and Africa heavily represented. We thank you very much. Now, from here, we are going to move to have a 10 minutes break. This is a health break, but at the same time, we do have what we are calling a networking lounge by two of our partners, Esri and Digital Earth Africa. They would want to showcase some of their work if you have a few minutes. And also we have virtual booths by our stakeholders. You should be able to see them on the list. Kindly log into the Hubilo app if that's not where you're watching us from. That's where all this will be happening. And you will be able to learn more about our stakeholders and the work we do even here at RCMRD. At exactly 10 minutes past 5, we will move into parallel sessions again today. The 4 thematic areas we had yesterday: agriculture and food security, weather and climate, water and hydroclimatic disasters, and land use, land management, and administration. These are parallel sessions. Please make a choice on where you want to be, and so that you can join and follow us from there. And after the presentations, we will have those presentations will be the last activity of the day. So the Hubilo app has been will be shared on the chat box of this. Our GIT kindly share the link to the Hubilo app. The links to the presentations are in that app, and you can just click join now directly from there. You should be directed to your session of choice. Once again, I thank you very much. Please don't hesitate to contact us for any further information or engagement. Thank you for being with us. Thank you, our speakers, Jenny, Dr. Macharia Meja, for making this session very insightful and enlightening. See you in the next 4 sessions. Thank you.
Thank you.